All right, let's try this again. Lesson 45 is ratio problems involving totals. What?
Ratio problems involving totals.
And analyzing a graph. What?
Analyzing a graph.
Very good. So we're going to learn how to make some ratio boxes where they give us a total. And then we're also going to learn how to look at graphs and tell a story from a graph, which is from the Common Core. So ratio tables involving totals. Acrobats and clowns converged on the center, reading the ratio of 3 to 5. What was the ratio? Get ready?
3 to 5.
3 to 5. So the ratio goes down the ratio column in the order that it gave you. Acrobats, clowns. So be careful. Make sure you write it in the same order. Acrobats, clowns, 3 to 5. Now, if you keep reading, there's a keyword total. Whenever you see a total in a ratio story problem, you're going to have a total row. So I'm going to total up my ratios in one column, but then in here I'm going to put my actual numbers. So the total is 24 acrobats and clowns. So that would be a total down here. So now I can find out how many acrobats, how many clowns. So pick the two numbers that you know. We're going to use those two. And then what is it asking? How many were clowns? So my question is, how many were clowns? So then pick these pair because this is what you want to know. Write a proportion. Our proportion would be 5/8 equals what over 24. And then using our cross product, we can solve a proportion. But I think some of you might see a trick or a shortcut. Joseph, what do you see?
8 times 3 is 24, so then 5 times 3 is 15.
Boom, he's exactly right. So that's our missing number. Let's make sure it makes sense. Is 8 the total a little bit bigger than 5? Is 24 a little bit bigger than 15? So that's making sense. Could I use that same multiplier in my table and say, oh, well then the acrobats must be 9. Check, is 9 acrobats plus 15 clowns equal to 24 total acrobats and clowns? Perfect. So now I know everything, but the only thing they want to know is 15, so we say 15 clowns. Box your answer, done. Let's do one more like that. A bus company has small to large buses in a ratio of 2 to 7. If there's 84 larger buses, how many buses does it have? So the ratio is 2 to 7. What is the ratio? Get ready?
2 to 7.
And it's small to large. There was a total of, sorry, not a total, there's 84 large buses. So I'm going to put the 84, that's a really big number, so maybe I should just put it in the total box because it's really big. That's what some students do. They say, hey, it's a big number, it must be down at the bottom. No, it's large boxes, or buses. So it's 84. Total up your ratio column. What number goes here, I think? You ready?
9.
9. And so I know this pair. What do I want to find out? How many buses does it have? It didn't say small or large, it said how many buses. So I'm looking for the total. I'm going to write a ratio. 7 over 9 equals 84 over what? Can we use a little shortcut here as well, Ethan?
84 divided by 7 is 12.
So the multiplier is 12. He found that by doing 84 divided by 7. We can use the same multiplier here, and then that would give us 108. That's our missing number. 108. Does it make sense? Is 9 a little bit bigger than 7? 108 is a little bit bigger than 84. How could I find this one? Layla.
You could do 108 minus 84.
Let's do it. So 8 minus 4 is 4. 10 minus 8 is 2. Should be 24. Does it check out with our multiplier if I put it right there? Yes, it does. So there's another way you can check your work. It should add up to 108. All right, give me a thumbs up. Makes sense. Ratio boxes. Raise your hand if you remember this from last year. Like this is a review. It's just a little reminder. Okay. Some of you is new. Weston, a little bit new. Or just is so easy. Maybe. Okay. This is the fun part of the lesson. This is the fun part for me to teach. All right. So we're going to analyze a graph. You look at this graph, and it really does tell a story. So we're going to learn how to find out what the story is behind the graph. We're going to do 2 of them. This one I'm going to guide you through. The second one, you're going to answer, and I'm going to call students. So let's read what it says. The graph below represents a trip made by a large delivery truck on a particular day. During the day, the truck made 2 deliveries, one taking an hour and the other taking 2 hours. Identify what is happening in each stage of the trip. Stages A through E. So this is stage A, stage B, etc. Let's look at the graph and find out what the axes mean. So the x-axis is labeled time in hours. So this would represent 1 hour of time, 2 hours of time, 3 hours. You could break it down into intervals between 4 and 6 hours. Something happened here. Well, then the y-axis is measured in distance, so 20 miles, 40 miles, 60 miles. So I could go, hey, from here to here, 80 miles was traveled. So let's break it down. I'll show you how I want you to write it. Interval A. Interval A went from here's here to here. It went from 0 to 2 hours. So in the first 2 hours, the truck went where? Now, did it go up a hill? Is that why this goes uphill? Is it going on a hill? No, but that's when I was your age, I thought that's what it meant. I was like, oh, it went up a hill, and then it got to the top of the hill. And then it drove straight across. Then it drove up a steeper hill. No, we got to look at it a little bit deeper than that. In 2 hours, it went 80 miles. It went 80 miles. That's all we know. But from 2 hours and 80 miles, could we find its rate, how fast it was driving? Rate equals distance over time. I remember that because I think miles per hour on the freeway. Right, miles per hour. So 80 miles divided by the time, 2 hours. That would be 40 miles every hour. So we have a rate. So already from that, we've actually found a rise over a run or a rate of change. We found a speed, and you're going to have to do this on the rise test. You'll say, find the greatest rate of change from the graph. When was it driving the fastest? Just look at the intervals. Distance divided by time. All right, questions? All right, let's do interval B. Interval B, looks like between hours 2 and 3 was interval B, and it's stuck here at 80 miles for a whole hour. It didn't drive any more miles, so it was doing a delivery, right? Okay, so hours 2 to 3, it stopped to make a delivery. It took a whole hour to do that delivery. It's a big delivery. So maybe a lot of boxes, maybe something big like a piano. Okay, interval C. Looks like it took off again. So hours 3 to hours 4. Okay, in the next hour, something descriptive. I said in 1 hour. What did it do in this 1 hour of time? It looks like from here to here, it went from 80 to 120 miles. How many miles is that? Liesl?
40 miles.
Okay, good. It drove 40 miles. Again, if we did distance divided by time, it's 40 miles per 1 hour. It's going the same rate as from here to here. So they're parallel. There's the same steepness. How about D? What happened at D? Who thinks they could describe what happened at D? Right, Connor?
It stopped for 2 hours to make a delivery.
Love it. It stopped for 2 hours to make a delivery. Abbreviated. Okay. Well, it's a long delivery. Okay. Did it have anything else going on? It said 2 deliveries, 1 to an hour, and there's our second delivery. Okay. How about segment E? Look at E. E starts from here. So 6 to 8. How many hours did E take? Colin? Took 2 hours. So the next 2 hours, what happened, Colin?
E went back to the beginning.
That's descriptive. It didn't keep going away from the beginning. It went back to the beginning. So I had to return at the 0 mile marker. Okay? It returned. So he's like, I'm hungry. I'm ready for dinner. I'm going to drive all 120 miles. So did he go 120 miles? Right? All 120, and it took him 2 hours. In 2 hours, so I could say his rate was 120 miles per 2 hours, or 60 miles per hour. So I know he's right here. Maybe he was the fastest on this way. His truck was unloaded and it was lighter. Maybe he was going downhill. Not because it's going downhill here. That's not a hill. Okay. All right. I think you guys are understanding this. So let's do this. We're going to describe every stage along this one. I'm going to call on students, and you're going to write it in your notes for your note taking today. what happened, describe for me a scenario, and this is gonna be Mr. Fisher. If you don't know, he doesn't have a car, so he drives to school every day on a bike. That's not driving, but he rides on a bike. So, and this is actually pretty accurate to what he does. The graph below is a distance time graph for Mr. Fisher's 3.5 mile cycle ride to school. During this ride, he rode on cycle paths, but the terrain was hilly. He rode slower up hills and faster down them. He stopped once at a school crossing, and at one point he stopped to mend a punctured tire. Can you already kind of see where his stops are? Here's a stop, and here's a stop. Okay. The graph shows his distance from home at any given time. Identify each section of the graph accordingly. So what I'd like you to do, take 30 seconds. For part A, will you describe what Mr. Fisher did in segment A? How many minutes he did it for, and what he was doing in A. Okay, put your pencil up if you've got it. Spencer's ready. Samantha, Lisa. Emma, what'd you put?
They went 5 miles in 0.5. Then he went 0.5 miles in 5 minutes.
All right, I think she's right. Here we go. Oh, you know what? I didn't mark off that we're going to call this 5. We're going to call this 7. Let's call this one 1.2. And there's one more over here. We're going to call this one 25. Okay, good. So 0.5 miles, that's the distance, and it took him 5 minutes of time. Perfect. We can figure out his rate. We do his distance divided by time if you needed to. Part B, what happened in B? Write it down in your notes. You've got 15 seconds. What did he do in part B? If you want to be creative in your story, you can. Okay, I want to hear what Aubrey wrote.
What? I wrote words.
It was good. I peeked at your paper. What did you write?
He stopped for crossing.
He stopped for a crossing. Okay, and how many minutes was he stopped for?
2.
For 2 minutes. Good. So from minutes 5 to 7. Now be careful. Some of my other classes, they were counting tick marks and they thought it was 1 minute. But no, you gotta look at the numbers. From 5 to 7, he stopped, right? He didn't have a distance change, so he stopped. Okay, line C, or segment C. What did he do? For how many minutes did he do it? Okay, let's ask, how about Holden? Holden, what happened in segment C?
He started riding down until he got to 1.2 miles.
Oh, okay. So he went he was biking until he got to 1.2 miles. What would you say the distance is that he traveled if he went from 0.5 to 1.2? Very good, 0.7. Okay, so he biked 0.7 miles. How long did he bike for? 7 minutes. 7 minutes. Very good. Raise your hand if you had that correct. Yay, awesome. All right, part D. What did he do in part D? It looks like, if you look at his rate, his rise over his run, it's there. All of a sudden here, his rise over run gets steeper. Doesn't mean he was up a steeper hill. It means he had a higher rate. That's a speed, right? He was biking faster, so something happened. He looked at his clock. Oh, I'm going to be late. Or there's a dog chasing me, which when I go from Stansbury to Erda, there was always a border collie that would chase me. So maybe that's where the dog came. Okay, figure out how many minutes did he take? What was he doing for segment D? All right, let's call on Lauren. What did you put? He said 6 minutes. How far did he go? 1.8 miles. Let's check. So at the end of D, it ended at 20. So you went 20 minus 14 to get your 6 minutes. Good. And then you went 1.8 miles. So you went for miles. You took this 3 miles. And he was at 1.2. So you did 3 miles minus 1.2 to get your 1.8. Okay, excellent. How many of you had that? Raise your hand. Okay, good. And part E. What happened at part E? So he was like cruising, he's running from that dog, And then something happened to E, and I think there was something in the story about a punctured tire. Maybe we can work that into the story. Something happened right here. Write that down. Put your pencil up when you've got it. Okay, let's hear from Colin. Colin, what's your story?
Okay, so he accidentally biked onto a landmine and it blew up, making a big hole in his bike, and he had to fix it for the amount of 5 minutes.
For 5 minutes. Okay, let's double check. So from, here's the 25 down here, so from 20 to 25, which was 5 minutes, he was on the landmine, or he had ridden over the landmine, blew up, and he's repairing his bike. I love it. That totally works. And it looks like he did get his bike repaired, which is good, because now we have segment F. Let's do segment F. Who thinks they've got segment F? Jasmine.
He got to the school that was now a half a mile away in 5 minutes.
Let's see, in 5 minutes, and basically he must have got to his destination, got to school, because that's the end of our story. Okay, awesome. 0.5 miles, so from here to here, 3 to 3.5, so that's just at 0.5 of a mile. And then looking down here, 25 to 30, there's our 5 minutes. Excellent. So we broke apart each interval. We interpreted from the graph our rate of change. We could divide our distance over time. We told a story, resting, going faster, going at a slower rate, going at that same slower rate, and then you can compare that rate to that rate. It looked pretty close. All right. Any questions? Raise your hand if you're like, I got this. Feel pretty good. Awesome. Very good. Okay, our last one is a multiple choice question, because another of the Common Core goals is you need to be able to identify or determine the rate of change and initial value of a function, and that's when you're giving a story problem. So here's a little story. A swimming pool has 100 gallons of water in it. Lisa put a hose in the pool and began adding more water at a rate of 15 gallons per minute. So here's our swimming pool. It's got 100 gallons to start with. When I hear that, and if I reword it in that way, 100 gallons to start with, I think, boom, starting amount, or an initial amount. This is the initial value that it's talking about. Then I start filling water into that at a rate, ding, 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 there's another keyword, rate of 15 gallons per minute. So in 1 minute I've added 15 gallons. Now I have 115 gallons. And then another minute later, I've got another 15 gallons, and so I'm at 130. This is not to scale, obviously. But you see how each minute I'm going to tack on 15 more gallons? So the question is, which equation would describe this story? Thinking initial value and a rate. I have a starting amount of 100, and then I'm going to add on 15 more gallons every minute. Which one would add on 15 gallons each minute, but starting with 100? Okay, what are your choices? Put your hand up when you think you know. Pencil, you know. Bo, what do you think?
I think it's D.
You're thinking D? Tell me how you're thinking about these right here.
Well, since it starts out as 100, add 15 every time. It make the most sense for me, because since 100 is the first one,
Oh, okay. Because you're thinking it's written first, so it's like what we start with?
Yeah.
Okay, that's a good idea. However, this 15 is going to stay 15 no matter how many minutes I am holding the hose on. In other words, I'm never going to get the 30. I wouldn't get a 30 out of this. If I times it by 2, I could get a 30. So I feel like because this is a rate, I'm going to need to be making this 15 turn into 30, then turn into 45. So how about, who have I not called on yet? Winry, I haven't called on you. What do you think?
C.
How many of you think it's C? A lot of you. Hey, you're right. And that one was a tricky one. I had someone last class think that because they were thinking, I know it's a rise over run because Mrs. Boone's been doing rise over run. So, okay, let's check it. I start with 100. That's an initial amount. And then I go 15 times 1 minute. That would give me my 15. 15 times 2 minutes. That would give me my 30. 15 times 3 minutes, that'd give me my 45, and that would end up working if I graphed it. My starting amount for my pool, I would start at 100 gallons. I'm gonna make it bigger. I'd start at 100 gallons. Okay? And after 1 minute, I'm gonna add on 15 gallons. After 2 minutes, I'm gonna add on another 15 gallons. So I'm gonna have a steady incline of pool water. Right, does that make sense? Give me a nod if that's making sense. Starting amount, and then I'm just going to gradually get more water. Notice it's not through the origin, so it's not a proportional relationship. And look at the equation. There's a plus sign. We're going to do another lesson on how to look at the equation and just tell if it's proportionate. It's not. All right, that is it for today. We're on page 310. Problems A and C. R is 4. Take a 20-second stand-up break.